Okay, transcended back here. Now we want to talk about superposition principle. So what is superposition principle? Now here we are just dealing with vectors. So if you know vectors, I don't think you are going to have any question with superposition principle. Okay, perfect. So now what we need to understand is we are still talking about electric charge, electric force, electric field, and everything. So now let's do a recap. We said if we have electric field going this way, okay, then we have, this is our electric field. Now let's take, for instance, we have what we can call our electric charge there. Now we are going to have two electric charge. Let's say we have the positive electric charge and the negative electric charge. Okay, and where do we expect these charges to go? Okay, so a positive charge is going to be following where the electric field they're going. So this guy is supposed to move in that direction. But when it comes for a negative one, the electric charge which is negative is supposed to be the opposite. Now, in general, what we are talking about, if we have a positive charge, we are supposed to be, is supposed to be going away here. So this is our electric field. What if we have the negative one? So they are supposed to be coming there. So this is our electric field. So we need to understand that principle. Okay, perfect. Now, what else are we supposed to know here? Now, guys, what we are supposed to know is like charges repel and unlike charges does what? Attract. That one we need to understand that. Okay. So now, what we need to understand is if we have two charges, a positive charge and a negative one. Okay, let's say we have two, and we take, for instance, this is negative, this is positive. Okay, now these two guys are going to attract each other, so we're going to have those forces in that direction. So the one which we have in between there is what we call the distance, which is R. So we can calculate the electric force to say the electric force is equal to K, which is constant, times Q1 Q2 over R squared. So we are going to take, for instance, this is our Q1 and this is our Q2. So this is how we can calculate the electric forces. Okay, and how can we calculate the electric charge? Oh, sorry, the electric field. Okay, you can calculate the electric field using this formula. The force, electric field, or electric force divided by the electric charge. So these are the formulas which we are supposed to understand. Now, there's another principle which we need to understand, very important. Now, this is the principle here. Now, what if we have got more than two electric charges? How can we calculate the net electric force? Okay, so we are going to take, for instance, we have two charges, or we have more than two charges. We have A, B, C. So we are going to say we have negative. We call this one as negative. Again, we call, let me say this one has to be positive. This one has to be negative. Okay. Or we can make this one positive to make things simple. Or if we can make another thing, we can do this. We make this positive. Yes, perfect. We make this positive, we make this negative. Now, the question can come to say, we can call this one as Q1. We can call this one as Q2. We can call this one as Q3. Now, what happens to what's going to happen at Q1 there? What's going to be the electric force at Q1? Perfect. This is what happened. Now, if we can check A and B, what's going to happen? These are unlike charges. Therefore, this one is going to be attracted there. Okay? So if that one is going to be attracted, then we have got a force in FB. Okay? Meaning the force is going to be in the positive direction. What of A and C? If we can check A and C, what's going to happen? this one is going to be repelled. Okay, so it's going to be repelled. How? Okay, so this, if this is going to be repelled, meaning this one is going to move in this direction, so we can call that one as f of SC. Meaning we have got two vectors going in opposite direction. So if we have got two vectors moving in the same direction, you can just add them. If you have got two vectors moving in opposite direction, you can subtract them. Okay, so if these two vectors are in opposite direction, you can say you have f of SC. You can calculate that. Okay, f of SC, you can calculate that using this formula. You use this formula. Now you are going to have the distance there. We can call that one as R1, and another distance there you can call it as R2. Now when it comes for SC, as you can see, it starts from A all the way to C, meaning the distance we are supposed to add, okay, supposed to be R1 plus R2 squared. So therefore I'm supposed to say it's going to be, okay, supposed to be R1 plus R2. You square it. That is going to be the electric force from F to C, or A to C. Then you also start there to say you start A, B. What's going to happen? K, Q1, Q2, you have your R1 squared. You find that. Now when calculating the F net, what you are supposed to do is you start FC is going toward what, negative side, and FB is going positive side. So you are going to say F of AB minus F of SC. The answer which we are going to find here, that will be our net electric force. So if the answer is positive, meaning this guy A was moving toward what? Toward the positive side. But sometimes you can have a situation where this guy is going in the same direction. F of AC and F of AB is going in the same direction. Then you can take it that way. Yeah. So another scenario which we need to understand is, what if we have these two guys or three guys, but they are in a they are in three sides. What do I mean when I say three sides? We have in X, Y, and Z. How can we do it? How can you find the net electric charge? Okay, here we go. Now, what we do here, guys, is this. Let's say we have got two charges. We have this. So we can call, if we have negative, then let's say we have positive. And we can call that one as Q1, Q2, and this one as Q3. Now, there we go. What if we have, yeah, perfect. We have this one as A, this one as B, this one as C. What would be the net electric force at B? So we start A and B. What's going to happen? This one is going to be repelled. Therefore, we are going to express a force in that direction. So that is going to be our F of AB. What's going to happen to B and A? These two guys are going to be attracted. So this is going to be attracted by that guy. So we are having a force in this manner. This manner. Meaning our net electric force is supposed to be in this direction. That will be our F net. Okay, perfect. Now, this is the same as if I have this. I just do that. So this is my F of AB. And this is my F of B. Or let me say F of BC. Okay. Now, this guy here is the same as that one, because there is everything is just the same there. Now, what comes next? What I need to do there is this. The only thing I need to do there is this. This part here, if this is F of BC, meaning this is my net electric force. So it's the same as I have something like this and this. Okay? It's the same. And I have the angle there. It's the same thing. So I have F of AB and F of SC. So see what happens. Now, as we can see, this is our F net. It's the same thing. This represents the x component, this represents the y component. So if I want to find that one, I can just take the hypotenuse to say f net is equal to the root of f of, so you are going to find f of b using the same formulas which you have done already to say k is equal to, or f a b is equal to k q1 times q2 over r squared. You are going to be given everything there. So there we go. We are going to say f of ab squared plus f of bc squared. You find there. Now, what if we want to find the direction? You say theta is equal to tan inverse. Then you say, since this one is present x, this one y, you say f of bc over f of sc. The answer which we are going to find here, that is our direction. Okay. Wonderful. Now, there are some other scenarios where we can have an angle, or maybe let me start it in this way to say, let's say we have two charges. We have two charges. Let's say this is positive. Oh, let me take it that way. Let's say this is negative. This is positive. Okay, now we know that electric field is moving from away from the positive, just like this. That is our electric field. Now we want to see the scenario where we have, let's take for instance, we have a positive charge. Now that positive charge is suspended in air. It's neither going up nor going what? Down. Now what's going to happen there? We know that if it is positive, it's supposed to be going there where we are going to have our electric force. So we know that if this guy is neither going up nor going down, we have the two forces going up and down is equal. So I can just take that guy here. Okay, so that is our positive. So if it is going up there, we have the electric force. There is another force which is driving it down, which is what? The mg. Okay, so we have, if this two guy is not going up, we can say the net force is 0. So it's going to have, our F is going up is positive minus mg is going down, which is negative. So I can come with the conclusion to say this. Then I can say my F net, or my F electric force, is equal to mg, because they are equal to each other. Now we know that electric field is equal to force, electric force over charge. Then force is equal to electric field times electric charge. I can replace electric field times this guy there. I say this. Perfect. Now from this equation I can solve anything which I have. Perfect, right? I can solve anything. I can solve electric charge, I can solve the mass. I can, if you have not been given the mass, you can solve the mass, you can solve the electric charge, you can solve the electric field using that formula. Perfect, right? Now there are some other scenarios where we have the same electric charge, but we have been given an angle. How can we drive it? Okay, let's start now. Now we want to see the scenario where we have the angle. Okay, where we have the angle. Now here we are. There we go. Let's take for instance we have this. Now something that is the charge, the positive one. Now we have the electric field in this direction. So those are our electric field. Yeah, we know that if this guy is going to have a mass, the electric charge is going to have a mass. So we are going to consider to say it is at equilibrium. When something is at equilibrium, it's not moving. The forces in x direction, they are equal. The forces in y direction are equal. Now, we want to drive a formula where we can, how can we calculate the electric field, the electric charges, the mass, the angle. Yeah, how can we do that? We know to say we are going to have the force going in this direction, which we can call it as mg. Another force which is going in this direction, which is the electric force. Another force which is going in this direction, we know that this one is going to act as our tension force. So again, we can create another force there, which we can call it as ty. Sorry, it's supposed to be tx because it is in x direction. Tx, this one ty. So as we can see, we have got the forces in y direction. Therefore, we can say the forces in y direction, we have, for it to be at equilibrium, meaning the forces in y direction, they are equal, meaning the ty minus the mg, then it's supposed to be ty is equal to mg. Now if we can check there, if we have the angle there, if I can take you back to grade 12, if we have got z, the angle which is there is the same as the angle which is there. Therefore, we can come up with the conclusion to say even the angle which we are going to make there is the same. So if we have made this angle is equal, then we can say if we want to find ty, this is ty, we can use cos. Why are we using cos? Okay, so cos theta, or I can put it here. Cos theta is equal to, adjacent is ty, hypotenuse is what? The t, the tension force. I can cross multiply. I'm going to find that t is equal to my ty is equal to t cos theta, meaning I can replace ty with t sin theta. So I'll come here and say, I can come there and replace ty with t sin theta. Okay, so I'm going to replace there t cos theta is equal to mg. Now if I have that, what if I want to resolve now? I want to resolve now the forces in x direction. In x direction, I have tx. So tx is supposed to be negative because it's going in negative direction. Okay, tx is going in negative direction. So I'm supposed to say my fa minus tx. Same applies here. Opposite here is opposite over hypotenuse. So we can say, we can replace this guy with t sin theta. Okay, then I can come here and say t sin theta is equal to my fa. Okay, so if I can divide both sides here in this equation, the first equation which we have 1 and 2. Okay, so I can just delete this so that we create a space here. If I can make the subject of formula as the t guy, I have this is equal to mg. So I want to make t as subject of form. I'm going to divide both sides by cos theta. So I'm going to have my t is equal to mg over cos theta. Now this t which we have here and that t is the same. So I can replace t with what I have there. Therefore, I'm going to have where there is t, I'm going to replace with the mg over cos theta times sin theta is equal to the electric force. Okay, I'm done with that part. I can remove this. Okay, if I can move that, I'm done with that part. Then the next thing I'm supposed to do is I can just make mg. I can put it, I can isolate it, then I say sin theta over cos theta is equal to the electric force. Now sine over cos is tan, so I'm going to have mg times tan theta is equal to the electric force. Now we also know that electric force is equal to electric field times electric charge. So I can replace this guy with what I have there. So I can have this electric field times electric charge. Now this formula which we have just come up with, I can find anything which I want. I can find the mass, I can find the direction, I can find the electric field, I can find the electric force, I can find the electric charge using the same formula. Perfect, right? There is nothing more you are supposed to know apart from this. Thank you for watching this video.